Yes, I said it. SQL like is dead. It can only match keywords, not meanings. Think about this real world problem. Your boss just handed you a massive resume database and a detailed job description. How do you find the best match? Will you use a simple SQL like to get the information? Can you use like to match resume with multiple skills and then rank them based on the best match? While like can get you a bunch of matches, it will not get you a ranking from the best match resume to the least match one, and you will be forced to open every resume to see if the experience is relevant. So, how can I get a ranking of resumes from the best match to the least best match, which can make my work significantly more efficient? And of course, the answer is AI and vector cosine similarity search. AI is everywhere right now. You have seen tools like ChatGPT or Gemini, which, if you did not know, rely on vector databases like Pinecone or VV8 to power their chatbots. But what if I told you that you can now store and query vectors directly inside Snowflake? No extra infrastructure needed. In this video, I will show you how Snowflake's vector columns work and how you can use them to power AI and semantic search right inside your warehouse. Let's take a step back. What is a vector? A vector is just a list of numbers that represent meaning. For example, the word dog can be represented as a vector list of three numbers starting 0.12, and a cat might be a vector list starting 0.11. And both these lists are in vector form. These numbers do not look like much, but they let machines understand data much more easily than if they were stored as cat and dog in text format. This is because computers understands 1 and zeros better than ABC. Apart from storing the text as numbers, vectors also provide something known as semantic closeness. Cats and dogs end up closer together in vector space because they share similar characteristics like four legs and a tail. The AI actually doesn't really know that cats and dogs have four legs and a tail. However, this similarity is captured in the vectors for cat and dog due to the AI training provided to the AI model, which means that they are actually close together to each other in vector space. As you can see in this diagram, the dog and cat are close to each other in vector space. However, the car is much further away as the car is not an animal. This is what makes vectors so great, that they can understand how close two words are to each other with the help of vector values, and this allows discovery of semantic closeness. So if I plotted food and bread in vector space, it will be closer than food and cat. What does all this have to do with Snowflake? Snowflake now supports a new data type called vector. So you can store these vectors, also known as vector embeddings, right alongside your structured data in Snowflake tables. Now the best way to learn Snowflake vectors is with the help of an example, and I will jump into a demo to show you how. I will start by creating a database called VectorDB. I'm calling it VectorDB, you can call it whatever you like. Next, I will create a schema called schema vectors. Again, this is a choice I made. You can choose whatever name you like. I'm going to create a table called resumes, which will contain resume information about job candidates. It has candidate ID, name, location, years of experience, and resume text. For this video, resume text is the most important field as I will be creating AI vector embeddings for it. I do need to add a new column called resume embeddings, which will hold the vector embeddings for the column resume text. However, I will do that later in this video. The table is created and I will insert 5 rows into the table. The insert is a success. Let me go ahead and select data from it. I am able to see the 5 rows I inserted. Time to alter the table and add our favorite column called resume embeddings. When you create a vector column, you need to tell Snowflake how many dimensions are associated with the vector column. I am choosing 768. You have the option of choosing 1024 dimensions too. Greater the dimensionality, generally better the performance of the vector search up to a point. The alter is a success and I need to populate the resume embeddings column with vector data embeddings. In this SQL, I am taking the values in the resume text and applying Snowflake Arctic Embed M v1.5 embedding model to the data in the resume text column to create the vector embeddings. This Arctic embedding model is a Snowflake embedding model and is automatically available for use in Snowflake. As you can see in this update, I'm applying embed text 768 to the resume text field and creating the resume embeddings. The update is a success and let us see how the data looks. I will copy paste the first row in a new sheet. As you can see, this is just the first row of vector embeddings and let us see how many rows are in the list. I will paste this list in Gemini and ask how many elements are in the list. As you can see, it came back with 768, which is what our embedding dimension model was. What this tells us is that if you set the dimensionality of your vector embeddings to 768, you will get a list of 768 vectors which maps to your resume text. I am back in Snowflake, and now that we have the embeddings in place, it is time to do a semantic search based on the embeddings I just created. Now, if we wanted to search resume for skills, we would use the like operator to match what we want in resume for skills. However, if you have several skills that you want to match in a single search and want to rank the resumes based on the closeness of your search from the closest match to the least closest match, then you can use vector similarity search instead of an operator like. And a vector similarity search in this situations is far more superior. I have this job requirement which says data engineer with Snowflake, which is a must have skill, and then DBT, Python, Airflow, and Kafka. Now, searching this kind of a job requirement with the like SQL operator is very challenging, and we will use the vector similarity search to basically search for this job requirement. To use vector similarity search to search these vectors, I first need to convert the search text, which is basically my job requirement, to vector embeddings because you cannot search text directly in vectors. Instead, you need to convert search text to vector embeddings and then use it in the search. So, how do you think I can do that? I can do that by using embed text 768, which is a Snowflake Cortex function, and it will convert our job requirement query to vectors so that it can be matched with the embedding column data. You are seeing the vector representation of a job requirement, and let us use this to do a search in resume embedding column. Search in vector columns is done with the help of vector cosine similarity, which instead of saying it is a match or not a match, will give you a score between 0 and 1, which will indicate how close the job requirement is to the data in the resume embeddings column. Closer the value to 1, the better the match. In the next query, I have joined job requirements in vector format with the resume table and compared the similarity between resume embeddings and job requirement embeddings. And when I run this query, you can see that it shows a vector cosine similarity score, which tells us which resume has a better match. As I just told you, greater the number, better the match. You can see the various scores that have been generated and use it to determine which resume to pick for further processing. You can use vector cosine similarity to search complex queries which cannot be searched with simple operators like the equal to sign or the like operator, and additionally, they definitely cannot rank the closeness of the match to your search criteria. I will order the match so that we can see the top matches first. The data is listed in descending order, and you can now decide what your vector cosine similarity cutoff should be and add it to the query by replacing the greater than 0 value, and you will have your list of matches. I will replace 0 with 0.70 And I am now seeing the top 3 candidates for my job requirement. And now I can call them to conduct the job interview. Let us check to see if the top ranked resumes are really the best match for the job requirement provided. The first resume has Snowflake, Airflow, DBT, and Python. This is a very good match and has most of the skills requested. The second resume has Snowflake and Airflow and seem to be a lower match than the first resume we saw. This is consistent with the lower vector cosine similarity score for the second row. The third resume has Snowflake and does not have any of the other skills and is the lowest match of the 3 resumes. If I continue with the other resume rows, which have even lower vector cosine similarity scores, you will see that they will have even further lower skill match. Now, in this example, I used 5 resumes. Now, imagine you were searching through, say, 5,000 resumes and you needed to hire one person. Would vector cosine similarity search make your search significantly easier? I am sure your answer is yes. I hope this video has provided you with a good idea as to how to use vector embeddings to improve your search and achieve functionality which is not possible with SQL Like. So, do you agree with me that SQL Like is dead? With that, we have come to the end of this video. If you found this hands-on lab helpful, give it a thumbs up and that tells me that you would like to see more videos just like this. And if you like to stay updated when I post new Snowflake content, make sure to subscribe to the channel. And finally, if you like to go even deeper and build a solid Snowflake foundation, you will find links to my Snowflake Masterclass and other courses in the description below. The Snowflake Masterclass is designed to take you from beginner to expert, so check it out when you're ready to level up your Snowflake skills.